Okay, so what we are going to do today is we are going to see how the transfer learning in CNNs work. ठीक है, I have discussed this concept in class as well. So can somebody explain what is the transfer learning? Anyone? Okay, so I guess you need to have a quick review of this on your own, but I'll tell you in brief that what is transfer learning. So in this, what we have is because in convolution neural network we have a large number of parameters as we have seen already. So it's difficult. So some networks are already predefined networks are there, and what we can do is we can use those networks and for example there is a VGG, there is some ResNet, and so many other models are already there. Already built-in models are there, and these models are already trained on huge data sets. Like there is a ImageNet data set which has more than 1,000 classes, and it's a very big data set consisting of, I guess, millions of images. Okay, so these models are already pre-trained on such huge data sets. So what we do is we just use already built-in knowledge, and we use those weights which are already been generated for the huge data sets already. So what we do is we use the built-in network, built-in model, and we just give an input our model, and uh, we can use we already trained parameters, we can use them. um, let's say, so in a transfer learning, I'll explain this. So let's say we have some model, let's say ResNet 50 or some other model. ResNet 50 having multiple layers in it. Okay. And this model is trained on a ImageNet dataset, let's say ImageNet dataset, and it gives, let's say, I don't know how many number of outputs it's giving. Let's say some n number of softmax layer. This is one softmax layer and n number of output labels it is giving. Now after this is already built in. We don't need to use. We don't need to. This is already pre-trained network. Now because this is a pre-trained network, so it has weights. Uh, Many already trained weights, and what we can do is we can use those weights, we can use those layers in our model. So in our model, suppose we have a data set that is, let's say, a cat dog what we are doing today is that is a cat dog data set, and we are, because this ImageNet has already classes of cats and dogs. Okay, so if I give this cat dog dataset as input, I'll use all these weights which are already pre-trained instead of learning this whole model again and again. So what I do is I use already trained weights, and then I'll build my model. Suppose it was having n number of layers. So what I will because it was having n number of layers. So what I'll do is I'll add, because I want to classify it as a cat or a dog, so I can add only one more layer. So this layer is added in the previous model, and this I can simply give output whether it's a cat or it's a dog. So this is my final softmax layer over here. So what I have done is I have taken the weights which were already built in from the ResNet. This whole model I have taken as it is, and what I have done is I have only added one layer, that is for classes that I want to classify. That is whether a cat or whether a dog. ठीक है. So this thing because I have taken weights for all the layers as it is, from W1 to Wn for all the layers. So what you can do is, we can also, there is a parameter that I have discussed in class as well, that there are few trainable and non-trainable. There are few, you can use this much number of weights and you can train the rest of the model. You can perform training on the rest of the layers. So here it will use 1 to, let's say, 5, and for W6 to N it will train the model. So for rest of the layers it will train. So that you can do. Also you can do for a percentage, for starting 25% of layer you can freeze, and rest of the layers you can use as it is. So what basically I'm trying to say is that depends upon you, that you want to use previous weights of all the layers as it is, or you want to freeze a few of them, and then you want to retrain the model. You can also retrain the model. You can also retrain the uh, whole ResNet model without freezing any of the layer. Now, so in today's assignment, what you have to do is you have to freeze first 25% and then check and train rest 75% layers, and then check how is your accuracy. And similarly, you have to proceed 50 with the 50%. So 50% layers, starting 50% layers you have to freeze, and the rest 50% layers you have to train the model again. Okay. Somebody is saying something. Okay. So this is what freezing implies. Now we have already built in networks: exception, VGG, ResNet, Inception, MobileNet, DenseNet, NASANet. So these are the basically types of convolution CNNs, and there are certain difference. For example, if you have seen Inception movie, so Inception nets are similar to, Inception. If you have seen that movie, you will know that Inception nets are there. And then let's say I'll discuss Inception net, and then I can also discuss, let's say, ResNet. Suppose, let's say, ResNet. So ResNet is a residual network in which there are multiple layers. The only difference in all these networks is interconnections is changed. In ResNet, instead of doing this process, it also adds one loop that is called a residual loop, or uh, additional connection, and it adds it to this layer. And then here addition is performed from the previous output, from the output from the one layer before, and the output from over here. So this output 1, and output from this layer, that is output 2. So all this is added in the layer, in this layer. So this is a ResNet. Similarly, for uh, this process is repeated for whole layers. So this is the architecture of ResNet. So the only difference is, this is a, let's say, convolution layer. This is layer 1, layer 2, layer 3, layer 4, and so on. So in ResNet you have just additional loop. So this is how ResNet works. And then simply, the only difference is the interconnection, type of interconnection they provide. Okay. In Inception networks, you have instead of because in a simple CNN, what we do is we have a input, and then we have a CNN layer, convolution layer, sorry. Then we have a pooling layer, then we have a convolution layer, then we have a pooling layer, and so on. So, and ultimately in final we have fully connected layers and fully connected layers, and we have uh, simply softmax layer. Okay, so this is the architecture of simple CNN. While in inception networks, the only difference is in the architecture. Here you have some input, then you have instead of all these, instead of passing these layers one by one, what they do is they pass all these layers, all these filters over here only. Convolution layer, and then let's say max pooling layer, convolution layer with 1 by 1 filter, convolution with 3 by 3 filter, and 5 by 5, and so on. So this is the architecture. Pooling layer with 2 by 2 filter, and so on. So all these things are passed in one layer only. So this is the architecture of our inception network. Okay, overall. But there are so many other details associated with this. I'm not going to discuss getting into much detail. Okay, so similarly, then this process is repeated, and so what is the inception is, so because this is one inception module, this is one inception module, this is second inception module, this is third inception module, and so on. And then finally you have output, fully connected layer in the end, and you have FC, and you have a softmax layer. So this is your final inception network. Okay, so but the idea in the inception network is each and every sometimes researchers have seen that they have applied over here itself, they have applied fully connected layers, and they have applied softmax layer, and they have get the output. So in the middle, if in the middle layer they are getting some output, so this is the inception basically. Network, sub networks in a network. So from middle layer also they get good. If you are extracting output from the middle layer, they at that time also they'll give you good output. Not that good as final layer, but yes, they'll give you some output. Okay. So that is why inception, that is sub networks inside a network. You can also add sub networks over here. At this point over here over here you can also add more, you can also add more layers, and you can then add fully connected and softmax layer, and then you can get the output. So this is a sub network inside a network. So this is how inception network is. Similarly, you have so many other models like mobile net, dense net, nas net, and so on. Okay, so what you have to do is you have to try all of them in today's assignment. Now it'll, because these networks are already built in Keras. Okay, so there's no extra effort you have to do, you just have to import these already built-in networks. Okay, now first step is you have this data set already. This is cat dog data set. You already have this data set you have worked with in the previous assignment, right? So you have this data set, you can download it from here. Then you can either use any data set of your choice, that is dogs versus human. You can create your own data set and then you can use that as well. Then you have to run the transfer learning with the mobile net and rest of all these networks. You have to run this. Now how to do that part? Let's have a look at the coding. Now, so in the coding, because you have already worked with the Keras, you know that there are uh, certain things that can be imported, like Keras models. You can import model like sequential model and so many other models. Similarly, Keras import, you can from Keras you can import Keras layers. So there can be multiple types of layers: dense layer, flatten, and convolution layer that you have already seen, pooling layer. Okay. And from Keras applications. So in Keras applications, if you have a look at Keras applications, you will find all the built-in networks, exception, VGG 16, 19, ResNet, So few of these are given in this assignment. DenseNet, NASNet, you will find all of these. DenseNet over here, okay, NASNet, and you can see the details. So it has so many number of parameters. Depth is 126, that is number of layers. Okay. In VGG16 you have 23 layers. Okay. So we'll see today the example of VGG16. This is a convolution network. Now you can read, if you click on any one of these, you'll find the complete details, what it is taking as input, what are the arguments, and what it is returning. Okay. So and there is a research paper, this research paper will give you the whole idea about how this network is already built. So if you want to get into more detail, you can read this research paper. Okay. They'll tell you which data set they have used and what was the accuracy for different VGG and other networks. Okay. So what I have done is, from Keras.applications, we have seen in Keras.applications, we have so many applications already, which was VGG16. So I have imported VGG16. Okay. So from Keras.applications.vgg16, I have imported that VGG16. Now I have assigned this to a model. In previous labs, what we do is we used to assign sequential model, and then we used to model.add and add multiple number of layers. Here I am directly using VGG16, that is already built in. Okay. And then if I want to see how this model looks, at that time what I can do is I can simply print model.summary. So if you do model.summary, you will see that first layer is having 224, 224, 3. So this is 224, 224 is the size of the first image that you have to give as input. So whatever you are giving, you have to reshape it to 224, 224, 3. Whatever you are giving 500 cos 500 image, you have to reshape it and you have to resize it to uh, 224, 224, 3. Okay. So this is first input, first layer, and then it has two convolution layer pooling layers, two convolution pooling, simple CNN, and then it has flatten, and then it has two fully connected layers, and then final output softmax layer, it has 1000 neurons. So you don't require 1000, so you have to add one more layer, that is for classifying cat and dog. Okay. So uh, this is, you have to add final one more layer after this predictions dense layer, that is already in there. Similarly, I have imported another inception v3 net, so I can see the model.summary for inception v3. So you can see over here, uh, it is the details of that network. Similarly, you have ResNet, and I have imported ResNet and model equal to ResNet model.summary. Summary you have already seen in the previous previous lab. So it has total number of parameters, trainable parameters, and so on. You can also import VGG19, and then you can see its summary. Okay, so what I have done is I have just imported a few of them, and you have to work with rest all of these networks. Okay. Okay, so after that, let us have a look at how you are going to use this VGG19 or this exception network, how you are going to use that now. So first thing what I have done is I have mounted my Google Drive simply, and because my drive contains cats and dogs dataset, and this dataset I can show you as well. It's not open already. Okay, just over here. So in the training dataset, that dataset I have downloaded, and in the cats folder I have multiple images, and in the dogs folder I have multiple images. I had uploaded this on my Google Drive, so I can see it over there. Okay. Now after I have mounted my Google Drive, what I have done is I am importing whatever is required. So I first is pre-process input and second is decode predictions. These two are new functions. So pre-process input is for reshaping your input shape because you require 224, 224, 3 as input. Okay. And also, okay, I will. So for in my VGG net, VGG 19, sorry 16, what we have is we have input that should have 224 comma 224 comma 3 input size, input shape, and output should be having 1000, 1000 in the softmax layer. Okay, that we have seen in the architecture of VGG 16. Just have a look. Am I audible? Anybody? Because network is. There's no response.
Yes, ma'am, you are audible.
Yeah. Okay. So I was uh, input is having 224, 224, 3, and output is having 1000 neurons. Okay. Oh, it's my network is still showing a bad network quality. I'm not sure if. Okay. Okay. So let us have a look at the coding part over here. So what I have done is I have read a single image, okay, and what I have done is I have resized it to 224, 224, and then I have stored it as an array and reshaped it in a tensor form, okay, or you can also flatten it simply. And then this pre-process input, if you have a look at this function pre-process input, what it does is it basically, this pre-process input function, if you have uh, So what it does is basically it changes your input shape, that is 224, 224, 3 to 1, 224, 224, 3, because we have only one image. So we have seen in the class also, this is the X, that is the number of training examples that I have, and this is the features that I have. Okay, so this function basically reshapes my input to a tensor form, that is a 4-dimensional form. Okay, so pre-process input changes image to that. After that, what I have done is I have stored my model into VGG16 model into model. Previously, what do we do? What we used to do? We used to use model equal to sequential, and then in last class we have done this part, and then we used to model dot add, and model dot add some layer, one layer, two layer, and up to n layers. After that we do in the last we do dense layer, and in the dense we give, let's say, two output neurons, and we give softmax as output. Okay, so this is how my model looks. Here I have directly used VGG16 in place of that model. Okay. Now model.predict, this is already we know. So to predict the values with the already built in model. So if you see what is in the YH80, so I have printed YH80, it's showing me 1000 values. Why 1000? Because in my output layer I had 1000 neurons. Okay, over here. So it will give me probabilities for each and every neuron. That I had given one image which was a dog image, and it is showing me what is the probability of each of all the 1000 classes that I have in the data set. Because data set it is using is ImageNet, and it is having 1000 classes, so it's classifying for all the 1000 classes, it's giving me probabilities. Now what I want to do is I want to use decode predictions. So decode predictions, what does it do is it out of all the 1000 classes, it will identify, it will give me the class with the highest probability. So class name, and this is the name of the dog that that input we have given, and and then it will give me probability. So this decode predictions functions, it gives for all the output values, it will give me the output labels. Okay, still it's showing bad network quality. Okay, now fine. So again what I want to do is, for the first image that I have given, I'm giving what is the type of the dog and what is its probability, which is 69.83%. Okay, so this is the final output. So I hope you know how this VGG16 works. Up till now, I want to ask, is everything clear up till now? Because we have to do transfer learning yet. So any questions up till now? Uh, in the middle of the recording, in the middle of this meeting, at some time it shows that bad network quality or my network is disconnected. So in case I'm not audible, just text, okay, that yeah, that I'm not audible. Okay, so because this is the half part that we have discussed yet. Abhi half part is remaining. Now in the rest half part, so up till now what we have done is we have seen how one model is built and how we can predict one, we can take one image and we can predict its class using VGG19 simply without modifying it, using it as it is without modifying anything about it. So what we are doing is we are training this whole complete model. Okay, now what if I don't want to use whole model as it is and I just want to use pre-trained weights? Okay, so using pre-trained weights is the basically the transfer learning part. So instead of retraining the whole VGG19 model, what we are going to do is we are freezing some of the weights that was already calculated from the ImageNet dataset. And for the rest of the layers, for the few layers I'll freeze them, and for the rest of the layers what I'll do is I'll retrain them. So up till now what we have seen is we have always been training the whole model. Now what we have to do is we have to freeze few of the layers. Okay, so let's see how that is done. So first of all, what I have done is that VGG16, you have to check the parameters in this VGG16. It you over here, you can include top, means you can either delete your first layer, that is input layer, you can delete or keep it as it is. You can set your weights or input shape, and other things are there. So what I have done is I have used the weights of ImageNet dataset that is already provided to me for the VGG16, and I have created one new object that is of VGG16 type. Now what I am doing is I am freezing from VGG's con model that I have created from VGG16 with certain parameters as input. For its layers, I am using colon, means I am using freezing all the layers of VGG16 as it is. Freezing all the layers means setting layer dot trainable parameter to false. So this layer dot trainable parameters provided to me with the model VGG16. I'll explain this in detail. So I have VGG16 model. Okay, it has, let's say, 22 layers. I'm not sure, 23 layers. Okay, so what I am doing is I am freezing all this. So this means VGG16 dot layers I have to set non-trainable. ठीक है. So what I have done is for all these layers, so if I want to uh, freeze these layers, I have to set the trainable parameter to non-trainable. ठीक है. So that is what I have done over here. Layer dot trainable is false and layer dot trainable is true, means that we are going to, it's by default true. ठीक है. Now this is, we are printing each and every layer. So all the 23 layers are printed. First is a convolution pooling we have seen in upper uh, part also. Layer dot trainable is the parameter and its value we are printing, so it's saying false. So for all the layers, the layer dot trainable parameter is set to false. This means now we cannot train the model and weights are freezed. So when we are building the model and when we are doing the prediction and fitting the model, at that time what it will do is it will use the already freezed weights over the ImageNet dataset. It will not train the whole model again and again, that it usually does. ठीक है. Now this is the simple thing that we already do. We create a model that is a sequential model. We add that layer that we have defined. VGG con we have defined already. So this is over here. This is VGG16 and we have already defined in a VGG con. ठीक है. So we are adding this layer, then we are adding flattening, we are adding dense layer. Simply we can add multiple dense layers. So I'm adding in the last dense layer, I'm adding 2 because I need a cat and a dog. Okay, so this is how you can add multiple layers. So in assignment part 2, here you can see you have to run the models with newly added layers 2, 3, 4 and so on. Okay, so what I am doing over here is I have added 1 and 2 dense layers. And flattening is done because previously we have images. So whenever in the convolution layer we have images, so we have to flatten and then we can use a fully connected layer. We have seen this part already. Okay. So now if I'm printing model.summary, it will show me VGG16. What is the output of VGG16? Then flatten will give me multiplication of all these three. It will give me 25088. Then dense layer and then dense layer again. And a dropout you can add or you can remove it as well. According to the if your model is overfitting, you can use dropout. If it's not, you can use We had discussed this in class, so just check whether your model is working fine or not. Now what is done is your model is created. So if model.summary is showing that your model is created in such a way. Now after all these steps, your model is created with freezed, with all the parameters freezed, with all the parameters of VGG16 freezed, plus 2 layers are added, that is fully connected layers. Okay, so this is your model for this first fourth point. Okay, over here you have added 2 layers additionally. Now after this, now you have created the model. So in previous assignment what you have done is, now simply whenever after you are creating model, what you do is you do model.compile simply, and then what do, you just do model.fit, you give your input training x, training data y, and validation data, that is text s and xy. This you have to take from the cat dog data set that we have already, you have link already. Okay, so you have to use that data set and try using the whole data set, because it's a big data set, and so you will know how this model is performing for the big data set, for the big data. Okay, and then we calculate accuracy, we print model dot weights simply, and we this whole part you have already done. You can print the validation loss and accuracy. Okay, so this is today's assignment. I hope it's not that difficult. थोड़ा सा difficult लगेगा starting में, it will, but uh, okay, you have time. Try doing it. I'll give after exams also you can submit. I'll give more time for submitting this assignment, because I know these things are new to you. Okay, so that's it. If you have any questions, you can ask. After that, we'll start with the vivas for the 2-3 students are left, I guess, in your batch. Let me see the list of students who are remaining. Please ask if you have any questions. So according to me, only 4-5 students are left whose viva is not done. So all of you can join the Google Meet link one by one separately. I'll share the link. Just wait a second. Join roll number wise, okay?